Hello, welcome to GED exam preparation class. I am your host and instructor, Ruben Herrera. And in this lesson, we're going to learn about powers and roots. Powers and roots. Okay, my friends. So let us look at these numbers right here. So I have the number 4 elevated to the second power. This number 4 right here, these big numbers that we see in here, they are known as the base or the integers. Okay, so this number right here, number 4, is a base, and these little bitty numbers right here at the top, these are called the exponents. Okay, this is the exponent right here for this number right here. Whenever we solve for powers, some students always make the mistake. They say, for example, oh yeah, this is very easy. This is 4 times 2, Ruben. 4 times 2 is equals to 8. And no, that is not correct. 4 elevated to the second power is actually equals to 4 times 4, which is equals to 16. The exponent right here is telling us how many times that number is going to multiply itself. Okay, it's not 4 times 2. It's the 4 is going to multiply itself 2 times. That's what it really means. So therefore, the answer of this power, or the answer of 4 elevated to the second power, is actually to 16. 4 times 4 is equals to 16. We're multiplying the 4 2 times, times itself. Okay, so now let us go to the next number right here. 5 elevated to the second power. Some students might say, oh yeah, this is very easy, Ruben. This is just 5 times 2 is equals to 10. No, it's not. This is incorrect. 5 to the second power is actually equals to 5 times 5, which is equals to 25. So 25 will be the answer of this number elevated to the second power. Let us look at the next number, 2 to the third power. 2 to the third power is equals to 2 times 2 times 2, which will be equals to 8. 2 times 2 is equals to 4, times 2 is equals to 8. So therefore the answer for 2 elevated to the third power is equals to 8. The next number right here, the last number that I have right here, is 3 elevated to the third power. 3 elevated to the third power, you guys guess right, is going to be equals to 3 times 3 times 3, which is going to be equals to 27. And we can go on, so on, so on, so on, with to the second power, to the third power, to the fourth power, to the fifth power, to the sixth power, and so on, so on. However, sometimes in math and on your GED and at school also, sometimes instead of saying to the second power, we're going to say square. We're going to say 4 is square, and instead of saying 4 to the second power. For the number 3, and instead of saying 2 to the third power, sometimes some instructors and some teachers, they say 2 cubic or to the cubic power. Okay, cubic, that's for the number 3. And pretty much only the number 2 and the number 3, the exponents number 2 and 3, are the only ones who have a special names. Like for example right here, this is 4 is square, 5 is square, this is 2 cubic, and this is 3 cubic. And then everybody else, to the fourth, the number 4 as an exponent, 5th and 6th and 7, you do have to mention them or explain them, like to the 4th power, to the 5th power, and to the 6th power, and so on, so on. But only these two exponents, the number 2's and the number 3's, they have their own special name. However, if you don't want to remember these names, you don't. If you don't want to memorize these names, you don't have to. You just have to remember them when the time comes. Remember, the 2 is a square and the 3 is cubic. All right, so moving right along. What if these, now we are solving for powers which bases have negative symbols, or which bases or integers are negative? For example, right here, I have a -4. And Sometimes your GED exam or in math, they're going to put parentheses. And this is not to make you confused, my friends. This is just to keep you organized. So minus 4 elevated to the second power is going to be actually equals to minus 4 times minus 4, which is equals to 16. But why? Why 16 positive? Well, remember the rules of the symbols that we learned in the previous lessons, where remember that a negative and a negative is equals to a positive. So we guys are going to have to remember this rule whenever we are also solving for powers or for exponents. We have to remember the rules of the symbols. But I tell you what, I have an easier way to do this. Let us look at your exponent right here. Look, my exponent is a number 2, and the number 2 happens to have a even number or a pair number. So I want you to guys think of this shortcut. This is what I call the Ruben's way. Look at your exponent. Whenever your base is negative, look at your exponent. If your exponent is an even number, your result is always going to be positive. And if your exponent is an odd number, like number 3, like number 5, 7, 9, if your exponent is an odd number, your result is always going to be negative. Okay? For example, right here, I have that now for the next number right here, I have 5 to the second power, or I mean minus 5 to the second power, or minus 5 squared is equals to minus 5 times minus 5, and that's equals to 25. It's positive because a negative and a negative make a positive, or you can also think because your exponent is actually a even number, so that's why my result is positive. Okay, positive results for even numbers and negative results for odd numbers. Let us look at the next number right here. Minus 2 to the third power, this will be equals to minus 2 times minus 2 times minus 2, which will be equals to minus 8. How is this? Well, because this, I have a negative times a negative is equals to a positive, and then times a negative is equals to another negative. Okay, but remember, we don't have to remember this. In this case, we don't have to go on and on and on with this negatives and doing negative times a negative times a positive. We can just remember, if that exponent right here is an odd number, then my result is going to be a negative number. This rule apply only when your base is negative, my friends. Do not forget about that. Let us look at the next number. Negative 3 elevated to the third power, or negative 3 cubic. This will be equals to minus 3 minus 3 minus 3, which is equals to minus 7. Okay, very nice. Uh, Moving right along. Now, what will happen, my friends, if instead of having a negative base or a negative integer, what if we have a negative exponent? And this is going to happen on your GED exam too. Well, this is what we're going to do, my friends. This is what we do whenever you have a negative exponent. We're going to solve for this exponent, for this power, the same way we always have. This is going to be 4 square. 4, or 4 to the second power, is equals to 16. But whenever we have a negative exponent, what we're going to do, my friends, we're going to put the result under a 1. Okay, just like this. 4 to the second power is 16, but because the exponent is a negative, we're going to put it under a 1. And why is that? Anyways, you may ask. Well, because whenever we elevate any number to a power, we are expanding it. But whenever that exponent is negative, we're doing the opposite, which will be compressing. So instead of being 16 times, it's only now 1/16. Okay, very nice. I did not wrote, the 4 times 4 this time because you guys already know the process. Let us look at the next numbers right here. Okay, 5 right here, 2 minus the second power is equals to 1 over 25. 2 elevated to the negative cubic, or to the negative third power, is equals to 1 over 8, or 1/8. Remember, 2 elevated to the third power is equals to 2 times 2 times 2, which is equals to 8. But because we have a negative exponent, it's going to be under a 1. Same thing right here with 3 elevated to that minus third power, or to the negative third power, is going to be equals to 1 over 27th. Very nice. And for example, what if now, let us look at this number. What if you have both the base and the integer, the base and the exponent, both negative? Well, in this case, both of the rules will apply, my friends. So this is going to be a lot to take and a lot to remember, but this is why we're going to practice, okay? And we're going to study hard in our books. For example, right here, for the first number right here, I have negative 4 elevated to the negative second power. That will be equals to 1 over 6. 1 over 16, I'm sorry. We put 1 over 16 because the exponent is negative, but yet the base is negative, but because the exponent is a even number, our result is going to be positive. Okay, so this is going to be very tricky and very hard, so we have to remember these rules, my friends. Okay, with the next number 2, uh, so the base is negative, but my exponent is an even number, so that means my result is going to be positive. Okay, but my exponent has a negative, so I'm going to put my 25 under a 1. Okay, and in the case of these last two numbers right here, well, we're going to have a double whammy right here. And notice that my results right here are both right here negative, and they're also under a number 1 because I have a negative 2, which is a negative 2 right here as my base in the case of this problem, but my exponent is an even number. So therefore, my result is going to be negative, and because my exponent is also negative, okay, I'm going to put it under a 1. And same thing with the last problem in here. Okay, very nice. Let us continue with our lesson of powers and roots. And now, the next thing we are going to learn how to do. Well, actually, we're going to learn some more rules with powers too. These are a little bit confusing. Okay, so for example, right here, my friends, we have some numbers elevated to the 0 power. And this is very easy to get confused because anything that we multiply times 0 is equals to 0. But when it comes to powers, we have an arbitrary rule. Okay, an arbitrary rule is that we just have to learn this rule the way it is, and most of the times, or sometimes, there's not an explanation for it, but we just have to learn that this is the way it is. 4 elevated to the 0 power, 5 elevated to the 0 power, 2 elevated to the 0 power. Any number elevated to the 0 power is always going to be equals to 1. That is correct. Some students they tend to get confused and put a 0, but no, it's actually 1. Any number, any base, any integer elevated to the 0 power is always going to be equals to 1. Now, on the other hand, sometimes we're going to have some integers or bases elevated to that first power or to the 1 power. And whenever we have that, those numbers are going to be equals to the same numbers themselves. So any number elevated to the first power or to the 1 power, since it's not going to multiply times itself, not even twice, so it's going to be just 1. So the result is going to be the same number. 4 elevated to the first power is equals to 4. 5 elevated to the first power is equals to 5, and so on, and so on, and so on, my friends. Okay, very nice. Now let us move on to roots. So what are roots? Also known as square roots. When it comes to square roots, my friends, it looks a lot like a division, but it's really not. For example, right here, it looks like a division house, but we're not really dividing by anything. And what we try to find right here, what is the square root of 9? A square root of 9, my friends, to find out what is the square root of 9, we need to find or find out a number that if we multiply it times itself, it's going to be equals to 9. In this case, my friends, that number 3, if we multiply the number 3 times itself is equals to 9. Therefore, 3 is the square root of 9. Okay, very nice. The next number right here, a square root of 16. Let us find out a number that if we multiply it times itself is going to be equals to 16, and that will be the number 4. Therefore, a square root of 16 is 4. Very good. What is the square root of number 5? Of number 25, I'm sorry, actually. The square root of number 25, yes, you guessed right. I'm already gave you the answer, is 5. Okay. Next, what is the square root of 36? Let's find a number that if we multiply it times itself is going to be equals to 36, and that will be equals to 6. 6 times 6 is equals to 6. Very nice, my friends. Now, these, my friends, right here, these numbers right here, this is what we call perfect squares. Perfect squares. And they're called perfect squares because the result right here, the results 3, 4, 5, and 6 do not involve any decimal numbers, or they're not decimal numbers, they're whole numbers. Okay, now there are going to be some cases where we're going to have some numbers like this: square root of 12, square root of 22, square root of 88, square root of 44. And to do the square root of these numbers is kind of hard. So what is the square root of 12? We need to find a number that if we multiply it times itself is going to be equals to 12. We cannot do this by head, or by using a pencil and a paper. We have to use a calculator for that. And it doesn't have to be a scientific calculator or a very expensive calculator. Any calculator will do that. I'm going to use my calculator right here that I have built in on Windows to do the square root of some of these numbers right here. Okay, for example, right here, I'm going to do a square root of 12. And unfortunately, calculators, they're not as standardized on how to make your key looks, or where to place the keys for the square roots. It's gonna look different on everyone's calculator, but on my calculator right here, this is what it looks like. This is what the square root symbol looks like. I believe on smartphones, on most smartphones like the iPhone, it looks like this. And then on Android phones, and then other calculators and other physical calculators, you're gonna see only the square root house, okay, or what it looks like, the division house. And sometimes it's going to require for you to press the shift key, and sometimes it's not. So you're going to have to learn that on your own, okay, my friends. So now let us look at what is the square root of number 12. So to find out what is the square root of number 12, I'm going to do this. I'm going to type right here 12, and then I'm going to press this key right here. Boom. And it's telling me right here that the square root is equals to 3.46. Okay, I'm only going to round it to the next two digits right here on the decimals, just the first two digits. Okay, for example, now let me do the next number right here, a square root of 22. In my calculator, I'm going to do right here 22, and then I'm going to press the square root key. That's equals to 4.69. Very nice. And this is how I do all the following square roots of this number right here that are hard to do by head or with paper and pencil, and I have to employ a calculator. I'm sorry. So now these results, my friends, because they involve decimal numbers, they are not perfect squares. Okay, they're not perfect squares. And all right, my friends, well, thank you very much for watching this video and this lesson, and I hope to see you guys on the next lesson. And you guys have a great day, and bye bye.